for everybody. Well, welcome everyone to our ninth class of Humanities Destiny, our Wednesday afternoon voyage, journey, adventure. I like adventure into the future. And in today's class, we're really going to start opening things up, because this is where we really begin to look at space. I want to give a little lecture on space exploration and new worlds. We're going to continue from where we left off last week, of course, but I didn't have a chance to provide you with some critical information about space exploration and new worlds. We had a good conversation, and of course, we had the good um, recommendation from Aria, the anime that we want to look at today. Hopefully, we'll get to that at the top of the hour at 2 o'clock when we start our discussion, or maybe a little bit earlier. As well, I know Ethan had something. I don't see Ethan here today, but he had the Cyberpunk 2077. But at the very least, since Ethan is not here and I don't see him online, we'll definitely take a look at an episode of the anime or something brief, maybe 3 or 4 minutes, that could perhaps focus on space exploration, but not necessarily. But we can definitely do. That was my instruction last week, to think about what we could look at from that vantage point. But we're going to continue then, as I mentioned, with the second half of the semester, which is that we're really opening things up now to the big future of what is in store for the human race off the planet, off Earth, not on Earth. And in the lecture today, I'm going to culminate with a very interesting new book that I've been reading and enjoying. And it actually, sorry, that's my pencil. It's called City on Mars. I will get to that shortly. It's written by two young scholars, one who is an illustrator as well, who's done some great illustrations in this, but also a professor from Rice University in the US. And the book is called City on Mars, but it's not what you think. It's very interesting. They actually pose a big question about whether we're ready to go to space and whether we should. And their answer, given that they say so many times that they're space nerds, tech nerds, they love all the new stuff, they want to just go into space, but then they have some very interesting things to say about the reality of what we're facing as we go into space. So I'm going to try and present you sort of two perspectives on this today about space exploration and new worlds. And then we're going to have a good discussion with a question that we have to ask. So does anybody have anything they'd like to say before we get going and I jump into a shorter lecture to give you some important things to think about, and then we will come to our great interaction and sharing of knowledge, which is what we do so well. All of you bring things into the class that can teach other students too. So we're all about sharing in this space here, sharing knowledge, sharing resources. But how about in the cosmos? Anything from Brooklyn, Sarah, or Yasmin that you would like to say before we get going? Anything on your mind? You can jump on your microphone or put it in the live chat. Looks like there is some thinking. Good, Brooklyn. Brooklyn, by the way, the instructions for the third reflection were posted. Did you see them? They were posted. Yeah, good. Okay. And did you notice that there's one thing I'm asking you to do in this third reflection that is different? Good. I see a nod here, Brooklyn. Brooklyn, are you able to jump on your microphone, or are we going to, is it just live chat today? Are you able to? If not, okay. So let's see. We'll go into the class for a moment here just to make sure that everybody is clear on what it is that I'm asking you to do that's sort of new. So I saw a nod. So I'll just go over to your default today because you were nodding. You weren't nodding off. You were nodding in agreement. So what exactly is new about this assignment?
You're asking us to use at least one source and then cite it.
Exactly. So now the research is starting, and it's going to continue into your fourth assignment, which is the big one where I'm expecting quite a bit of research. Okay. So yes, go ahead, grab Mike and get into the global classroom headspace, so to speak. Yeah.
Can we use the lectures as a source?
It's a good question. I am going to say right now, for the purpose of this assignment, no. You can, of course, for the final assignment, but I want an independent source outside of the lectures because I'm curious to see what you use as this one source, and then what information you provide from it and how you provide it. Okay. So just for the sake of this one, no.
Okay, that's
Yeah,
all I
good
need.
question. Absolutely. Okay, anything else? Yasmin, how are you doing today? You always have something on your mind and something that needs to be said. So do you want to say it, or is it not really needing to be said?
The brain isn't working too well, but I watched Interstellar once again, and it reminded me of when we were talking about love and space. So
You watched which?
Interstellar,
Oh, sure.
and
Yeah,
how he goes,
yeah.
and love and Murph and all that stuff. So it made me think about last week's class.
Yeah. No, absolutely. And it's not something we would ordinarily kind of touch on, Yasmin. You know, we often talk about space exploration and we focus on machines, tech, and new places. But then this question of what humans can bring and what is important, I'm really glad that we touched on that because it's more important than you think.
For
And
sure.
yeah, it has been said, by the way, that of all the animals on this planet, it's humans that have this capacity to love and care for other humans that goes beyond any other animal in terms of our concern about how we take care of the ill, how we bury the dead, and how we respect that part of our kind of journey on this planet. So the question of how we love and how we feel for others, hopefully, my hope is going to be that it's only going to get deeper as we go into the future. But just to put it out there before we get going on the lecture, there have been quite a few science fiction writers, quite a few visionaries and people thinking about the future who worry that the amount of technology in our lives and the way we use technology is dehumanizing us, making us unable to love as much as we have in the past. We might get so attached to our machines and rely on them, and machines are cold. They're soulless so far. So there might be a final assignment kind of in that topic right now for somebody who wants to take it on, which is what exactly will be the role of human love over the next few hundred years as science, technology, and engineering ramp up even more and we use those things even more in our lives? What happens when we rely so much on those? And people said that about the pandemic as well, in terms of our reliance on Zoom, our isolation, and our need for constant stimulation from our social media platforms now and our inability sometimes to detach ourselves from our machines. It's making humans more stimulated, more hyper, more distracted, and more unable to feel deeply about things, which is a darker view. I'm not saying that's necessarily true, but it might be a question for somebody to take on in the final assignment. What exactly will be the role of human love over the next few hundred years? Will it increase? Will it diminish? And if it increases, how are we going to use our love? Where do we put it? Am I making sense? Is that making sense? Good. Okay. I always have to check in and make sure things are making sense. So let's talk about this idea of new worlds and about space and about where humans are going. And I'd like to start this lecture off with something that's happening right now in terms of a new world. As I was walking over here from my office, I reminded myself that today is March the 13th, 2024, and I am walking from my office to here in a t-shirt. And I'm walking across a field where the grass is there, but it's not green. It's kind of dried out and a different sort of color. And I was appreciating the weather and the t-shirt, but at the same time, I couldn't help but think that this is not normal. This is not natural. I do recall not too long ago that there was snow. There hasn't been much snow this winter. I would not be surprised if today sets another record in terms of the temperature, which is supposed to be 18 degrees in March. For better or for worse, this is a new world. The fact that I am walking and I'm not sure what season it's going to be tonight, and I wasn't sure what season to dress for this morning, is an example of change, of things happening. And it is complex, but we can define this in a very simple way as a new world. Am I ready for this? Are you ready for things changing? How should we approach this? But I really want to talk about something else, which is the idea that we are in a new world in terms of that so much discussion today and even a lot of business interests are being directed towards leaving the planet, of going somewhere else, of using the machines that we've created to get us further. This image you're looking at right now is not a doctored or photoshopped image of the planet. It's actually an image that was just taken a few years ago by a lunar orbiter in 2015. NASA has a particular orbiter that goes around the moon. It's about 150 kilometers from the surface of the moon, and it goes around the moon in its orbit. But as it's doing that, it takes pictures of Earth as it's doing that. As Earth rises, for example, on the horizon of this orbiter. This has to be one of the most striking images I've seen in quite some time of our planet. You're looking at the Africa right there. That's the Sahara Desert, the brown part right there, and this image probably for you is something quite common. You probably see images like this a lot, but maybe you haven't seen something so vivid, so real, and so haunting at the same time. This idea that we are seeing our planet like this on a routine basis is new. In a way, we might say that this is a new world. Two, new worlds are not just about what we discover, it's about perspective. It's about how you look at things. And the idea of a perspective that we could have of our planet in such vividness is something that is completely irreversible in terms of our future. We're going to be working with this idea of living on a planet going forwards forever now, unless something happens and we move somewhere else in the solar system and we become more involved in the conditions there. This is a very important way of understanding what I mean by new worlds. I mean, today it's about what we discover, but it's also about the perspective that's shifting for humanity or might be shifting. What I want to do in the course of this lecture over the next 20 or 30 minutes is try to understand exactly what is space and what's happening around us off the planet. What do we know about the other parts of our solar system or galaxy or beyond? And I want to help orient all of you to this so that you can understand how to think about this, because many people are now, and your career choice may be dictated to some extent by this as well. You may choose to enter some field that has space exploration or the instruments that are being developed to go into space. There are aspects of human psychology and the human brain and the human mind that we are learning from astronauts as we study them. People who go into space, only a few hundred people only a few hundred humans have been in space off the planet, and even fewer, many fewer, have actually walked on another body in the solar system, and that is, of course, the moon. We've only been to the moon. You don't see the moon in this picture, but let's first orient ourselves to this idea of what a solar system is and what a galaxy is, what stars are, how big are we talking about, what kinds of scales are we looking at, because this really is awesome and mind expanding, but it can make us kind of dizzy at the same time to be able to get ourselves around some of these numbers. But this is real now. This is part of our reality. We are looking beyond the Earth. So first, I just want to check online with everybody. Do you see nice and clearly the big board and the image of the solar system behind me? Yasmin, are you good? Great. Okay, because one of the things I'm really trying to do with the global classroom is make sure that everybody who joins us, whether they're remote or here, are all referring to the same thing. Particularly when I'm showing videos too. Everybody is interacting with the big board. It doesn't matter where they are, online or here. So this has got to be really nice and clear. Okay. So before we start to understand something, for example, about could there be another type of intelligence out there? Is it possible that we are on the verge of finding some kind of planet or something else that would have the ingredients of life? Are you or your children or your grandchildren potentially facing a future where we are going to make some critical discoveries about something off Earth that could fundamentally change the way we look at life on Earth? Or is this all just hype? And these are important questions for your future. But I want to take you back now to when you were in maybe grade 4 or grade 3 and you were learning about the planets and our place in it. And we're going to have a little bit of an astronomy, very basic astronomy lesson to get people kind of reconnected to space and an understanding of what it is. Does anybody feel comfortable telling us what we're looking at right now? Like, what are the planets? How are they lined up? What's what? And what's that big orange thing right there? And why is it so big? And why are the other things so small? Or would you prefer that I just walk you through this and refresh your memory on this? Because we're supposed to know this, but most of us knew this when we were children, but then we forgot. But we can't forget anymore. This is important stuff to know. Anybody online want to, Brooklyn, how do you feel about, oh no, you're only on live chat, so you're lucky. I will save you some potential discomfort by just explaining it myself. And I will admit to you that when I was actually a few years older than any of you are, and I really started to develop this idea of teaching human history and human story, I didn't even remember myself exactly where Venus was, or, you know, why is there such a thing called the Goldilocks zone, and what's Pluto, and why do we call it a dwarf planet? And I had to go back and review and study again all those things. Okay, so first, let's really try and understand the big picture here. We are now talking about the universe. That's what we're talking about. But that's not what you're looking at. You're looking at just a very small aspect of the universe. So let's try and just open our minds for the moment to this immense scale called the universe. And I will need somebody to take some notes. Let's see who's ready. You all look so incredibly connected to the big board. I don't want to rip you away from the couches. So I'm going to wait for a little bit before I. Oh, rest in peace, Pluto. Yes, but Pluto is no longer a planet, just a little dwarfy planet, but it's still out there and we're learning things about it. But thank you, Yasmin. I just saw that. Rest in peace, Pluto. The universe is something that we have only begun to understand in terms of its features and what is in it in the last 100 to 200 years. Human beings, through science, are just waking up to reality in some ways. All of what I'm about to tell you has been there long before we ever entered this story. But we humans are just starting to become aware of this, and we're beginning to develop the tools and technologies to see this. We just put a new telescope out there called the James Webb Telescope that was just launched, and that's allowing us to see further and further and to understand more about what's really in space. So forgive me if every so often I say things like, we are still just children here in understanding the reality of what we're dealing with. But first, when we talk about scale, we're talking about the universe. And the universe, as far as we know, the universe contains everything that I'm about to say, but I need to kind of put it into something very simple for you. When we talk about the universe, we're basically talking about stars. Stars are gas, and stars are the original engines of everything that started to evolve from them, the metals and matter and other mass. So, for example, the sun is just one star in the universe, but it is everything for us in terms of what's happened here. So, the sun, in terms of its heat and its light, is the battery of all life and all things that are happening in the sun's system. We call that the solar system. So everything that happens around our sun is the solar system. And I'll get to that in a moment in terms of the planets. But in the universe, there are billions and billions of solar systems. And the way it's organized is that we have the universe. That's the biggest picture we have of energy and matter and mass, of stuff out there. But then we organize it into galaxies. So we have stars that started the process of everything that has happened here. But in a galaxy, there could be about 1 billion or more stars. And there are about, could be, hundreds of billions of galaxies in the universe, as far as we know. So let's get a sense of this scale right now. We, on planet Earth, revolve around one star, our sun. We are in a galaxy that has potentially billions of more stars. Our galaxy is called the Milky Way galaxy. So that's just one galaxy of billions in the universe as we understand it. As I explain this, you're going to start to wonder, if it's so big and we know so little, surely we're going to discover something eventually. I'm going to agree with you. I can't wait, but I'm not going to be a kind of champion who will be so enthusiastic and tell you it's going to happen soon. But when you look at the scale of what we're dealing with and what we know, and when you realize we're so small and we know so little, it's like we've just put our foot in the ocean and we're about to go swim into the ocean and we're just dabbing our toe in it now. You start to get a sense of, wow, what's going to be coming? Okay, thanks. Yasmin, oh, Brooklyn. Way to go. Now, Brooklyn, I'm going to ask you an honest question, but if you don't tell us the truth, we probably understand. Did you Google that, or did that just come out of your head? it's okay. You don't have to. You did not. You promised, Brooklyn. We can't see you. We can't check your body language. You absolutely promised. It came out of your head. That's very good. Okay, so let's see. We'll get there in a moment in terms of understanding what's in our solar system. While we're here, I'll just let's see what Elon. Apparently, according to NASA, there are more trees on Earth than stars in our galaxy. Ooh, interesting. Well, we can always touch on that, but you know something, Yasmin? I will tell you something as an answer to that right now, and then I will get to it in the end of the lecture in about 10 minutes. Most people who've been to space, astronauts, including the authors of this book, A City on Mars, who have not been in space, but are exploring, should we be in space? Many of them, come on in, instead of getting really excited about space when they're in space, they actually end up becoming more excited about Earth. Because having left the planet, they get to see the planet whole, and that increases their appreciation of the awesomeness of Earth. And actually, I'll wait until I get to the end of the lecture to tell you about a little song that comes from Russian cosmonauts that is quoted in this book about grass. That you can't get grass yet, as far as we know, anywhere else in the solar system, but you can on Earth. And these Russian cosmonauts came back to the planet and they decided that what they love the most is not space, but grass. So, in other words, what Yasmin is putting her finger on is sort of interesting, but I don't want to get onto a tangent yet, okay? So we're dealing with a scale that is so large. Space is big. Let's get our mind around this for a moment in terms of numbers, okay? When we talk about the Milky Way galaxy, our galaxy, we're talking about a disk that kind of looks like fried egg, a fried egg, and it's moving around. If you were to see it properly, and in the middle of that egg right now is what we're beginning to learn called a supermassive black hole. We're learning more and more about what exists at the center of galaxies, these black holes that are so powerful. They have the most overpowering gravitational force. Gravity is so strong in these black holes that anything that gets close to it gets sucked right into it and can't get out. And the reason they're called black holes, as far as I have from my research, do you know why they're called black holes? Does anybody know? This is the right answer, but it's not yet the perfect answer. You can't see them, okay? We can't see them, but we know they're there because they're sucking things in. So there's this blackness. But why do we say black hole? That's right, but there's a earthly meaning for this. Do you know why? No, apparently. According to Jana Levin, who is a professor in Columbia University in New York, and she's a novelist and she's also an astrophysicist. She's won a lot of prizes for her work. She did a little digging on this. There once was a prison in Calcutta, in India, which was infamous. Infamy is the opposite of fame. It's you're known for awful things. So infamy. So in this terrible prison in Calcutta, you never got out and you disappeared into the black hole of this Calcutta prison. If anybody can find information that challenges that or provides a different view, please bring it to the class. But Jana Levin, who's a very good astrophysicist and who has studied this a lot, is somebody I put some faith in terms of her research. And apparently this is why it was called black hole to begin with. So when we talk about the center of our galaxy, we're talking about this black hole, but more importantly is scale. Do you know how the distance is from one side of the disk to another in terms of numbers? Like let's start to get into data here to open your mind and see if you can get your mind around this scale. From one side of the Milky Way galaxy to the other, and then in a moment I'm going to tell you how thick it is. So fried egg in your head right now. Massive, massive fried egg. It's bursting your brain. It's so big, but you see it. Big fried egg, but kind of thick fried egg, and it's sort of moving a little bit, and the kind of the white part is moving around the yellow part slowly, and the yellow part is really black because it's a black hole. So what is its actual not circumference? It's diameter. What's its diameter, right? Good, Zach. What's its diameter? 100,000 light years. Now, let's have some fun for a moment, okay? Somebody must go to the smartboard now because we're going to mathematically break down 100,000 light years and what that means in terms of zeros, because I am hoping that the Gravol I forgot to bring today, but should have brought, I would be able to give you some of it after this because you're going to get queasy. You're going to feel like, oh, it's so big, and like I'm getting kind of nauseous here. The scale is so immense. I'm getting kind of travel sickness, or no, maybe not. You're all used to this. Okay, so I think we're going to put Aria over there because she's going to have to write down some other stuff. Could you go back to the board for us today, Aria, since you're a good scribbler, and we'll see how things are. And Brooklyn, since you're on top of things and things just pop out of it, make a new slide. Just bring you got it, okay? And we'll call it the Milky Way. The Milky Way. And we'll say for the Milky Way, what is its diameter? And I've said 100,000 light years. Okay. Brooklyn, off the top of your head, What exactly is a light year? What's that? A Buzz Lightyear. A Buzz Lightyear. Oh, God, thank you. It's a movie I haven't seen, I confess. So, how is Buzz Lightyear used? Like, what is its meaning in Toy Story? It's a name of a character? He can fly. Ooh, good. So we're going to get the actual fastest thing in the universe shortly, which is Buzz Lightyear. Good. Okay. So we've got some. Oh, she has no idea. Good. So you don't know something, Brooklyn. I'm glad. Okay. So we're going to break this down. This is really hard to do. First of all, a light year is not about time, right? It's about distance. That's the hard thing first. That we use this term, physicists, cosmologists, people who study the universe. It's called cosmology. The light year is just a way to explain distance so that we don't have so many zeros in terms of understanding distance. So here we go. A light year distance. Well, light travels at 250,000 kilometers per second. So this is the fastest thing that we know of in the universe. Albert Einstein helped us. So let's do the math on this. Watch this. I want to break your brains right now in terms of scale. Stretch your brain so much that it can't go back to its original dimensions. I'm going to break it. Is that okay, Zach? Yeah, stretch it, okay? Okay, so 250,000 kilometers per second. Good. Now, when we talk about a light year, we're talking about how far light travels in 1 year. So let's get our mind first around this fact. Light, a photon of light is the fastest thing, and I guess that's why we have Buzz Lightyear, the character in Toy Story, okay? He flies and he's fast. The circumference of planet Earth is 40,000 kilometers. So I'll bring you back here to get a closer view, okay? So if you go around our planet, or, you know, this is a kind of a dying planet here, that's a living planet, but we're going to bring it back to life, okay? 40,000 kilometers around it, okay? If light moves at 250,000 kilometers per second, how fast is light in terms of going around the planet? How many times would light, a photon of light, go around planet Earth in 1 second? 40,000 kilometers, 250,000 kilometers per second. So in 1 second, how many times does it go around the planet? Excellent, 6.25 or something. I think I might have to start bringing out the Gravol a little bit, okay? Can you get your mind around that? Just think for a moment, because in terms of our destiny, we need to understand space. We need to understand cosmic scale, global scale, which means we have to understand large things. If you can't do that, you're not ready. You're small. You're earthly. Do you want to be cosmic? Don't you want to be bigger? So 6 point, what's the math exactly on that? 6 point, so it takes light. Light can go around the planet 6.5 times in 1 second. In 1 second. That's how fast it is. Albert Einstein, who everybody knows as the ultimate nerd and brilliant geeky scientist who helped us to understand gravity. And you okay? Oh, yeah, you good? He dreamed when he was about 16, 17 years old. His dream was to ride a photon of light. Imagine having that kind of dream that you're looking up, you're looking around you, and you're dreaming of being that fast, of riding a photon of light. Okay, so now we've established how fast light moves. So then let's get the distance in terms of light year. Well, we would do something like this. It's going to get to be a lot of zeros. 250,000 kilometers per second. How many seconds are there in 1 year? Let's do it. Watch this. And then you'll get a sense of what we're dealing with. How many seconds? Yasmin, can you do that off the top of your head? How many seconds in a year? What do we have here from Sarah? A unit of astronomical distance. A unit of astronomical distance. Well, we have something. Sarah's kind of there, but let's have some fun with the zeros. Just for me to make a point. So how many seconds in a year? Okay, Eric, could you write down, and it's not Ethan, what's his name again? Daniel, sorry. Could you write down the number Daniel just gave, which is 31,536,000 seconds in 365 days, 1 year. Previn, yeah? Okay. You write so well, like in terms of clarity. Yeah, I almost want to hire you as the scribe, the global classroom scribe. Okay, but that's really nice. Are you hearing everything? You're good? Yeah, okay. So what, Previn? What do you got? Oh, do we have billion here, or is it 31,536,000, or is it 31 billion? Okay. Ooh, because billion sounds more like it, but let's make sure our math is correct. Okay? Yeah. Oh, here we are. We've got it from Sarah. Sarah, are you able to jump on your microphone? So we have Sarah's also reporting 31. Okay, that's fine. 31,536,000 seconds in 1 year. So then, now, here comes the big part. How far does light travel in 1 year? Well, we'd have to go 250,000 kilometers per second times 31,536,000 seconds, and now we get our distance. Let's do that. Let's break your calculator. How far does light travel in 1 year? What's a light year? Because we're talking about now the measurement of distance in terms of our galaxy. The diameter of the galaxy is 100,000 light years. So we have to establish what is a light year. A light year is not time. The year part is confusing. It's distance. That's why, okay? So then let's Area do this. This is a work of art that she's created. It's nice. So yes, do you want to tell Area what to write? And actually, we want to make sure that the Cosmos hears this. So Daniel has the answer in terms of how many zeros. So what's the answer?
Are you ready? So it's 7, 8, 8, 4, and then 9 zeros.
9 zeros. I'll ask Sarah because Sarah's on this. If we go up from billion to trillion to quadrillion to quintillion, do you know what we're talking about, Sarah, in terms of the terminology we would use at this point for, is it quintillion? Is it sextillion? It's sextillion. Okay, we're not getting to Google yet, are we? There we go. Did you know that Google is, okay? Of course you do. Just need to check. But you can imagine the guys who created Google thinking about this kind of stuff. They were, right? How many zeros in a Google? 100. Okay, so we're dealing with, Zach, would you be able to read that out to us with the microphone here? 7, 6, sex. Hold on.
Zeros.
Sextillion or quint. Go ahead.
I think we got. Whoa. So,
Yeah, it's on. I think it's on.
ooh,
Yep.
yes.
Go ahead. Go ahead.
All right, so I'm gonna guess that's 7 nonillion 884. No, that can't be right. Yeah, octillion, something like that. It's a big number.
It's a big number.
I'm not gonna
okay.
attempt any further.
Yeah, I'm not going to test you on this. I'm not going to even quiz you. But we're not done yet. The light year, we have one light year. The Milky Way galaxy is 100,000 light years. So now 100,000 times this. And now we're going to get the distance of just our galaxy. So, let's get this figured out. 100,000 light years times 7, and I'm not sure if it's sextillion or septillion or Daniel? Yeah, okay. Oh, so she's going to have to make a new slide. We want to see the number of zeros. That is the whole point of this exercise. No, I want to see the zeros written out. That's just lame, times the 10 to the 10 or whatever. No, we got to see the zeros. So go ahead.
You might want to stretch your wrist. So it's 7, 8, 8, 4, and then 17 zeros.
17.
Yeah, 1 7.
17. Yeah. Okay. Wow. Okay. So that's one galaxy. And we have potentially billions of other galaxies in our universe that we know of. So again, given the scale of this, with the fact that every single galaxy like ours is this size or even bigger, I think you want to be alive 300-400 years from now, or even less, because the odds of us discovering something. But let's get smaller now and bring this back to our little patch, the solar system. You think there's, I don't think so, Brooklyn. We're beginning to almost be certain there is. Let me explain, okay? Is there another Earth in our galaxy? Let's get the scale. Maybe new slide. Thanks. This looks great, Area. Really, and it's nice and clear. Will be a great thing to study for later. Our galaxy is 100,000 light years across. It's also 1,000 light years thick. But you don't have to put, you can just put, don't worry about it, okay? We'll keep it clean for now. We just want to give you a sense of the scale. I don't have to give you all the the numbers. In our galaxy, there are, let's say for conservatively, there are about 1 billion stars. So there are a billion solar systems because every star has its own little system around it, planets and other things that revolve around the star. It wasn't that long ago that we humans, as smart as we thought we were convinced that the world was geocentric, meaning that everything revolves around us. We figured out eventually through, some free-thinking scientists, Johannes Kepler, and Isaac Newton, and even the Greeks long before that were beginning to understand that we are a heliocentric world. Everything revolves around the sun. So Brooklyn asks a good question about could we be uncovering or discovering other Earth or Earth-like objects or planets in our galaxy? Well, guess what? We already are starting to narrow it down to what's called exoplanets. Have any of you heard that term, exoplanet? Yes? Okay. Can you write down exoplanet for now? This will help us to understand a bit more about what's happening around us. Exoplanets. So Brooklyn, I'm going to explain this in a moment about what an exoplanet is, but for the moment, XO means extrasolar, like outside our solar system, in another solar system. Exoplanet. That's what the exo part means. Out of our solar system, in another. Okay? But first, I just want to make sure that we've got our basic sort of astronomy down. And let's go back to what Brooklyn, and I've never actually done this in a class, is I'm actually incorporating what the students say in the live chat right into the lesson in this way, like going, this is cool. And I think it's because I've got the live chat now close to me and it's working better. So let's see if Brooklyn had the right order. Okay, so can you, Daniel, what does it say? Okay, she's saying Mercury first. Yeah. Yeah, the Mars and Earth need to be switched. Exactly. Yes. Well, we say we'll try to not, you know, let's say, sort of confuse our imagination today with this body part, this human body part, and we'll try to think in a more, larger way. So we'll go Uranus, but we could say Uranus, and then we have always, everybody will start to laugh because we have our human moment. I mean, every one of the 8 billion people on this planet has one. But that's enough, Sid. Okay? So, Uranus. Okay? The only mistake there is the order of Earth and Mars, right? Mercury, so it should be Mercury, Venus, Earth, Mars. Those are the 4 rocks. We're the 3rd rock from the sun. Okay? Then we get into all just gas. And we have the rest. And then we have the little dwarf planet, Pluto. The only thing that needs to be said about this order that's really important is that as far as we know from cosmologists today working in this field, people who are studying the structure, order of the universe, they're not astronomers. They're not just studying the objects in our solar system, but they have a much larger view of the whole universe. And as far as we know, in terms of our knowledge, we know that there are all these other solar systems. We know that there are other planets just next to us in another galaxy called the Andromeda Galaxy. That's the next galaxy to us. But then the next solar system to us, which is really close, that's only about 3 million light years away from us. The next solar system is called Alpha Centauri. And exactly, Proxima Centauri is a star. Actually, I believe it's 2 stars. I'm not, I think it's 2 stars. Proxima Centauri is 2 stars we've discovered in the next solar system. And around those stars are planets that seem to exhibit the same constituents or properties that Earth does in terms of potentially having the ingredients of life. Now, what makes Earth unique and miraculous, really, is that it's in this special zone called the Goldilocks zone, not too hot, not too cold, from the sun, because everything close to the sun, like Mercury, Venus, and Mercury and Venus especially, are just too hot, you know. And then we get into Earth, which is cooler and warmer, and Mars, which is cooler. But Earth has got just that right, not too hot, not too cold, and we say it's just the right place. With Proxima Centauri and the other exoplanets that we're discovering, they seem to be in the similar zone, the habitable zone, the Goldilocks zone of their stars. But we don't know enough yet about what's there. We haven't got close enough yet to see what's on those exoplanets. So Brooklyn, it may be that if we can get close enough to the planets, the exoplanets that are orbiting around the 2 stars in Proxima Centauri, I think I've got that right, but it's close enough. We may discover something in terms of a microorganism or more, something alive, which would be, just imagine being alive for that. You know, the headlines, the world, you know, everything. We have found living things elsewhere off the planet. They're growing. They're reproducing. They're mutating. They have a metabolism. They're responding to stimuli. These are all the properties of life, constituents of life. Imagine being alive for that. Maybe it's way off in the distance. I'll come to the live chat in a moment because I want to stop. I love talking about the science and I love talking about space, but I want to make sure we have a chance to interact a little bit more. I haven't finished the lecture. Is it okay if I take another 5-10 minutes and we can still interact like this? And then we'll stop for discussion because it's really important that you hear something from these two, Kelly and Zach Weinersmith, called A City on Mars. How can I say this in a way that continues to inspire you, but at the same time will be realistic? I think I would put it this way. In this course, Humanity's Destiny, we're talking about things that haven't happened yet. It's about the future. It's about the human imagination, about the human desire to explore. It's about where we are going in our solar system and beyond. I've tried to bring some reality to this too. That's why, excuse me, in the early part of the semester, we had a class called Thinking About the Future, and I tried to give you some techniques from Paul Sappho about 6 rules for effective forecasting, because I didn't want you to feel that it's too pie in the sky. The truth is, there are so many people today who are talking about space. And there are countries now that have begun their own space programs, no longer working with NASA as partners. For example, Russia, China, India, and others, particularly China. It used to be that in the early parts of the 20th century, when space exploration really began in earnest with the Apollo programs in the 1980s, or sorry, the 1960s, the 2 primary players were the United States and the Soviet Union. And they were in a Cold War at that time, and that was what was pushing them on. But now, so many people are in the game. And we have the richest person in the world, Elon Musk, you know, who he loves attention. You know, he just can't stop talking about things. But I just don't want to go on about Elon Musk. It's not fair. He's brilliant, of course he is, but he's also dangerous when he opens his mouth about how we should live our lives. That's my view. Okay, just my view. Be careful when he speaks, because he's not that smart when it comes to sociology and how people should behave together. He's no different than Donald Trump in what he says. But he's also a brilliant engineer, and he started some great platforms, PayPal, and hybrid cars with Tesla, and now SpaceX. And in A City on Mars, the Weinersmiths write a lot about Elon Musk, and with some respect and also fascination with the fact that he doesn't seem to be able to practice any kind of real birth control. He seems to have a lot of children with a lot of women, which is what rich people sometimes do, is they don't really I gotta stop. What did he name his kid? Centauri, Proxima, Pluto, Venus, something or other? Numbers in his name, okay. But the fact is, for better or for worse, Elon Musk is an extremely important person in your lives and my life, because he's the most enterprising and the most ambitious about space exploration and about what humans should be doing in space. In this book, A City on Mars, these two authors, scholars, thinkers, visionaries had planned to write a book. They tell us a lot that originally, when they began writing this book, they wanted it to be about humans colonizing Mars. They wanted to be writing about the fact that it's going to happen soon in this century, and here's what it's going to be like. But the more they researched this, the more they talked to people in the field of space exploration, of the development of the tools and machines that are taking us into space, the more they began to see that it's going to be much more difficult to deal with than anybody is saying at this point, particularly Elon Musk, that there are things that money and ambition are going to have a great deal of difficulty contending with. And their view was this, in a very simple way: humans have not figured out how to manage conflict. If you look at the world around you, there is so much intercultural conflict between so many religions, so many peoples, and it's violent. Their view was, these visionaries who are talking about space as being the next frontier are also saying they think that we will start with a clean slate, tabula rasa, that we will begin a colonization of the moon or Mars or another part of our solar system, and we will start fresh. And we won't have the same problems that we had on Earth. In other words, in their estimation, it made them uncomfortable thinking about the fact that it's not possible that space is going to solve our problems down here. That a lot of people who talk about the human quest, the need to go there, the fact that we landed on the moon already, it was the world's greatest technological achievement in 1969, by far, when Neil Armstrong, to give you an idea of how it was so great, just a few weeks ago, the United States heavily promoted their return to the moon, what's called the Odyssey landing craft. All this hype. Nobody was in this actual device. It was just a kind of a exploratory rover type of craft that would land on the moon and explore. So there were no humans in it. In 1969, there were 3 humans who got down onto the moon and walked, and Neil Armstrong walked for 3 hours with Buzz Aldrin on the face of the moon. Here we are in 2024, all this hype coming out of the United States. They land the Odyssey, and guess what happened? The Odyssey fell over. Nobody's talking about the Odyssey much now. The view that they put forth in this book is very interesting. I'm not saying that I support it. I want to make sure you hear this. We need to be realistic, and we need to be wise. And their view is, if we take our conflicts into space, and we start to create weapons to protect us in space, and if we go to war in space, as we go to war here, and I don't need to tell you how cruel war is now. If you had been alive during the Second World War, you would have only been reading about the savagery and cruelty at the front in a newspaper days later. Now, TikTok. Whoa, you're seeing people get blown apart all the time. It's very disturbing, but that's war. Their view is, we humans need to grow up before we think of going somewhere else. Because if we go somewhere else and we're still children, we're gonna fuck it up big time. And a lot of people are gonna get killed. The environment will be destroyed, and it will be irreversible. So please, they said in this book, to all of our friends, they were writing because they know all of these people in the space program. They interviewed them. They believe in this idea of going there. They said, we think we need to think about this in a way that ensures that down here on Earth, we're doing better. And this is very consistent with what I said at the beginning and Yasmin said. The more we go into space, the more we think about what's there, the more we start to appreciate what's down here. I'd like you to think about that, Daniel. Well, you know, Daniel, in a very simple way, kind of. Yeah. Without having to reach to Hollywood, although Star Wars is a classic, so we'll put that somewhere else. It's like Lord of the Rings, you know, beautiful movies and they're philosophical, but yeah. Let's think about what's down here. And they quote this wonderful line by a Russian cosmonaut. I just want to read you this. And then we're going to stop. We just cannot convince ourselves that the usual arguments for space settlements are good. Space settlement will be much harder than it is usually portrayed without obvious economic benefits. Attempting space settlement now may increase the likelihood of conflict on Earth in the short term and ultimately increase human existential risk. Even the awesomeness of the view out of a Martian habitat is not worth all this. And then This is the lovely part. I got to take this off because I like reading this. See, I like books, things you can hold in your hand, like, no computer, just you can turn the pages back. Like, this is sophisticated technology. I don't have to scroll back and then look. I got it right there. Russian cosmonauts have an anthem called The Grass by Our Home. It is a profoundly 1980s ballad, renditions of which typically involve a guitar, and at least 3 mullets. Not sure what that is. I have to check. A mullet. Mullet again? No. I'll find out for you. I'm having a moment of ignorance. But it contains some surprisingly moving lyrics told from the perspective of a man in space contemplating Earth. The chorus goes like this. We dream not about the roar of the cosmodrome, not about this icy blue space. We dream of grass, grass by our home, green, green grass. We dream not about the roar of the cosmodrome, not about this icy blue space. We dream of grass, grass by our home, green, green grass. Having devoted all this time to trying to see a more realistic vision of space settlement, one of the few things we can say with certainty is that we have more appreciation of this grass by our home. In fact, not just the grass, but the home itself and the people inside it. This is what happened in 1968 when we thought we were going to land on the moon for the first time. Do you know that there was a mission 6 months before? December 25th, Christmas morning, 1968. 3 astronauts are up there going around the moon, but they can't land. It's just too dangerous. 6 months later, they will go back and they will land. That was Neil Armstrong. But that Apollo 8 mission in 1968 is legendary. Not because we landed, but because we took the first photograph of the planet. It's called Earthrise. It's something like this that you're looking at now, but this is a much more contemporary version. Earthrise was just this little planet rising, on the horizon of the moon, being broadcast on live television around the world on Christmas morning, 1968. And the astronauts were reading from Genesis. They were so moved. I remember this. I was 6 years old. We went to space, and what did we do in the end? We learned about the Earth. Kind of an interesting thought. I'm going to stop there for a moment, and we're going to continue. This was a little long today, but I really wanted to give you a good lecture. Haven't done this in a while, and this is so important now as we begin to look at our destiny, is what is our purpose going to be in space? What are we supposed to be doing there? Just because we have the machines, and just because we have wealthy people who are launching cheaper rockets to get us there, okay, that means that Elon Musk gets a lot of attention for every time he develops the new engineering that has cheaper propulsion and cheaper rockets. So what? I don't agree but I need you to hear this and think about it. And what I will do is I'm going to stop today. We'll stop a little early. And unless there are things you'd like to say and we can talk a little bit, we're going to continue this next class. But I want to make sure I get you thinking about your third assignment and the final assignment. So first, Aria, is there anything that you think you would like to write there or even draw right now that relates to today's lecture that you think is really important? You're free to do it. Okay? And you could draw it if you want. You don't have to. Okay? But stay there and think. That's all I'm asking you to do because she's got a creative mind, very creative. It's good. The anime, we could look at it now, actually. Why don't we'll end the class by looking at a little anime. We don't have time. Show us a small clip, okay? Let's look at a small clip, and we'll try something new with the tech for you. I think I can have you share your laptop with the big board here. So let's do that. But Daniel, good. I like how you distill things down to something very simple and direct. Go for it. I think they're nuts. No, I mean, it's not fair to say. There are landing tracks up there. There's a flag up there still. But more than that, because somebody could say, a conspiracy theorist could say, that that was put there, fake, it's all. If you look at the history and the number of people that came together to make those missions happen, particularly the 1969 mission, talking about thousands of people came together at NASA and around the world. It just, from the standpoint of humans coming together, it's hard to believe that it could be faked with so many people involved. Somebody would have to come out and say, of all those thousands who were involved, this didn't happen. The program I was a part of was not true. It was a lie. So the other thing, too, I want to remind you of is, do you know how many satellites there are right now up orbiting the planet, satellites that provide information for all of our devices? Plenty. We humans do things and we build things that are pretty awesome sometimes. And we should be proud of that. What we did with the moon landing was awesome and real. And I think that those who say things like that will go to their grave trying to tell you that the earth is flat. And I will even say one more thing, Daniel, to help you understand. There's a very good evolutionary biologist named Jerry Coyne out of the University of Chicago. He wrote a book called Why Evolution is True. There are many, many biologists like him, but he said, once he was speaking at a conference, a very well-attended conference of successful business people. Successful, educated, you would think people who understand something about science, technology. A man came up to him at the end, one of the people in the audience, and said, Jerry, everything you've just told us about evolution in terms of how it started with cells and then multiple cells and then, that humans have emerged from lower forms of life and grown from primates and others is, yeah, and the evidence is there. I still don't believe you. In fact, he said this to Jerry. This is incredible. I know it's true, but I still don't believe you. Some humans have an emotional block, in my estimation. in dealing with complexity. And we have many examples of this in the world, I'm afraid. A person who says we didn't step on the moon or the earth is flat is not quite able to open themselves to the complexity. It's something emotional almost. They know the facts, but they won't accept it. I don't know why exactly, but an emotional block. You might know some people like that. Beware of people like that in your life because they can get violent. You got to be able to talk to them. Okay, so does that make sense? Kind of? Yeah. Okay. You know, it's okay even if you. I have students, many students from different places, and I try to help, and I've learned how to really understand where people are coming from, and you know, I'll stop there. Okay, for now. Okay, so let's look at anime, and I'm going to do this. Okay, I'm going to try. There is this. If you enter into your search browser the IP address, and then you follow this, in theory, it will mirror your laptop and we'll be able to run the video from your laptop. Let's see if it works, okay? And then we're going to finish. We're going to end the class with a bit of anime, which is all fine by me. Any other questions? I'll come back to the live chat and let's just see what we have over there while we have here for a moment. I'll do it this way. Hold on. There we go. Okay. So how are we here? Where's my cursor? Come on, cursor. Is it working? So it's a Mac? Chrome. So let's see. So it's a Windows or I guess is it Chromebook? Okay, then you know what? I don't want to mess things up. Why don't you just send me the link, okay, in my email? Because you have to download an application. Oh, it's from
streaming website, and I have Premium, which allows me to watch the episode.
Oh, but you can't send it to me? Can you send me the link or?
Not unless I like download it.
Okay.
The episode.
Why don't we say, let's try and get something for next. Can we go to YouTube and find something that is like that?
Go to YouTube and find the episode.
Let's see if we can do it quickly. If not, then we'll wait. Okay, so I'm going to just, hold on. I'm going to set, so that's not going to work. Let me do this, okay? We'll do, that's, oh, I see what the problem is. Extended, okay? We'll come back to main here, okay? And then we'll come back to pod over there. Okay, so I'm going to do this for now. And hello, cursor. Okay, there we are. We'll go to YouTube and we'll go to my YouTube channel. Search would be Iron and Blood. Mobile. Okay, Mobile Soup, Iron and Blood. I think I've got it here. Is this it? Okay. Episode 1? Okay. Well, I'll just go episode 1. Oh, I even saw it there. Here? Okay, so let's enjoy this. Sit back and I mean, for me, it's the first time I've seen this, so probably it's not for all of you. I'm going to put this link in for our. Here we go. It is episode 1, Iron-Blooded Orphans. Hmm. And why'd they take it down? Okay. Oh, I thought maybe it was pushing the envelope or something nasty about it. Okay, so let's watch a little bit, and I'll just go from the start, or is there a place you think I should shuttle to? Okay. Great. Here we go. I'll start a little earlier. Uh-oh, somebody's getting something implanted. Yeah, I like that. Audio? What? Good. Ah, good. Yeah. Oh. Hold on. Next class, we'll come back to this, and I'd like you to explain a little bit more about what is happening off the planet to humans, okay? And we'll continue as and exploring this. But thanks. At least we've started, and we can run it this way. And I would like to use this as a teaching tool. Next class. All right. Great. So everybody, third reflection is going to be due on March the what did I say? 20th? 26th. Yeah, March just before our March the 27th class. Yeah, good, Previn. Thanks. Okay, so you know there's that one thing about the source, and then be ready for the big final assignment that's going to be coming soon. An assignment sheet will be posted. You'll have lots of choices, and you will also have a choice on how you do it. For the final one, 1,400 to 1,500 words. But you could do a video, or you could draw it, or you could do anime. You can have a choice on what medium you choose to express it in, okay? It's a reflective essay presented as either a paper, a video, a presentation, a painting, however you want to present it. It's a reflective vision of the future. You could. I will give you that option. Nobody's yet taken up that option in a while But if we do that, then I will make time in the final class for presentations and we'll put it on YouTube. We don't have to. Previn? Yeah. I'll explain more as we get closer, but essentially you put them in the credit roll. You do a credit roll at the end and you say these are the sites to use. Okay? That's how I've been doing it. Good. Nothing else, Daniel? No more good, succinct, to the point questions? How's it going online, Sarah? Okay, great. We'll see you. We're done. Sarah, anything you'd like to say before we sign off from the global classroom here? Okay, have a good week, and we'll see you next week. Great. I'm here if you need. Okay. Yeah, have a good week. Let's see.